Forget everything you thought you knew about 3D printing. What if I told you there's a printer so impossibly precise, it mimics the deadliest insect on Earth to build objects smaller than a single cell? This isn't science fiction anymore, and it's about to change medicine, electronics, and even reality as we know it. You heard that right, a mosquito. An insect often dismissed as a pest is now the blueprint for a revolutionary technology capable of fabricating structures on a scale previously thought impossible. Prepare to have your mind blown, because we're diving deep into the tech that turns a blood-sucking nuisance into a tool for unimaginable creation. Before we get to the printer, let's talk about the mosquito itself. We typically swat them away, but their feeding apparatus is a marvel of natural engineering. A mosquito's proboscis isn't just one needle, it's a bundle of 6 distinct tools, each designed for a specific function: cutting, spreading, sensing, and injecting. Think about that precision. It can penetrate skin, locate a capillary, inject an anticoagulant, and then draw blood, all while minimizing pain to avoid detection. This biological ballet happens on a microscopic scale, with components thinner than a human hair, moving with incredible speed and accuracy. It's this unparalleled biological precision, the ability to manipulate fluids and tissues at the nanolevel, that engineers at a secretive new lab, let's call them biofab innovations, decided was the key to unlocking the next dimension of 3D printing. They weren't just inspired by it, they reverse-engineered its core mechanism. So, how do you turn a mosquito into a printer? Biofab Innovations developed what they call the proboscis array printer. Instead of a conventional print head, imagine an array of microscopic nozzles, each one a biomimetic replica of a mosquito's proboscis. These aren't printing plastic, they're working with bioinks, conductive polymers, and even individual cells. Each microproboscis can precisely inject or extract materials with incredible accuracy, down to single nanometer increments. We're talking about building objects atom by atom, molecule by molecule. This isn't just small, it's molecularly precise. They've even incorporated a neural feedback system that mimics the mosquito's sensory hairs, allowing the printer to feel the material it's working on, adjusting pressure and flow in real time. This level of control means they can create intricate structures with unmatched resolution and integrity, far beyond what any laser or extrusion printer could ever hope to achieve. This isn't just an evolution, it's a revolution in fabrication. The implications are staggering. With the proboscis array printer, we can now build things that were pure fantasy just years ago. Imagine designing and printing customized drug delivery systems that are literally invisible, micro-robots the size of a red blood cell that can patrol your bloodstream, identifying and destroying cancer cells with pinpoint accuracy. Think about truly microscopic sensors that can detect environmental toxins at levels previously undetectable, or even fabricate neural interfaces that can directly repair damaged brain tissue, restoring sight or movement. We're talking about printing fully functional, complex microscale electronics directly onto surfaces, or even within living organisms. The printer can create intricate cellular scaffolds for regenerative medicine, precisely arranging stem cells to grow new organs layer by molecular layer. This isn't just about making things smaller, it's about making them perfectly functional at the most fundamental level. This isn't just a printer, it's a portal to a new era of biological and material science. But here's the twist, with such incredible power comes equally incredible risk. What happens when you can fabricate self-replicating microbots that can reconfigure anything at a molecular level? What if this technology is used to create bioweapons that are undetectable until it's too late, or surveillance devices so tiny they can't be found? Imagine the privacy implications if microprinters could be deployed to subtly alter physical objects or even biological systems without anyone knowing. The ability to manipulate matter at this fundamental level is a double-edged sword. It opens doors to unprecedented progress, but also to unprecedented peril. The ethical discussions around this technology are already heating up, with calls for international regulation and oversight before these microscopic marvels become macroscopic threats. The line between creation and destruction has never been thinner, or more precise. If you're finding this as fascinating and terrifying as I am, hit that subscribe button. You don't want to miss our deep dives into the future of tech. Let's keep exploring these incredible, sometimes dangerous, innovations together. While the proboscis array printer is a conceptual marvel, the underlying principles are very real. Researchers worldwide are actively exploring biomimicry for microfabrication, drawing inspiration from insects like mosquitoes and even smaller organisms. Labs at MIT, Harvard, and companies like Nanoscribe are already pushing the boundaries of 3D printing down to the nanoscale using techniques like two-photon polymerization. While they might not be using a literal mosquito, the idea of leveraging nature's precision for microscopic construction is gaining massive traction. The next 5 years will see prototypes of these mosquito-inspired printers move from specialized labs into more accessible research facilities, democratizing this incredible power. We'll see the first human trials of microprinted organs, personalized drug delivery systems, and perhaps even the initial steps towards neural enhancement. This isn't a distant dream, it's happening right now, driven by the unlikely inspiration of a common insect. So, next time you see a mosquito, remember, it might just be holding the blueprint for our future. If your mind isn't completely blown yet, then you're probably not paying attention. Seriously though, if you want to stay ahead of the curve on the most insane tech breakthroughs, hit that subscribe button and ring the notification bell. We're just getting started. From a blood-sucking pest to the architect of our future, the mosquito's journey into advanced 3D printing is a testament to nature's genius and human ingenuity. The ability to build at the molecular level promises cures for diseases, unimaginable new materials, and a complete redefinition of what's possible. But it also demands our vigilance. What do you think? Is this the future we've been waiting for, or a Pandora's box we should keep closed? Let me know in the comments below, and don't forget to like this video if you want to see more mind-bending tech deep dives. Until next time, stay curious and keep building the future, one microscopic layer at a time.